last time we showed you how to use multimeters. Today we're going to show you how to actually convert power into something useful for your circuits. We're also going to see the amount of power that's taken up by heat when you use a linear regulator. This is a linear regulator. It is model number LM317. It's actually an adjustable linear regulator, and you can adjust the voltage coming out of it by changing the resistance in a potentiometer. So I'm going to make a circuit that basically looks like that what's on the whiteboard there. And then we're going to test out how efficient this regulator is. Pin 1 is going to be at the top. So according to our schematic again, pin 1 is voltage in, pin 2 is voltage out, pin 3 is our adjustment. Okay, now with our adjustment what we need is to make what's called a voltage divider. So with our voltage divider, we need to have a 240 ohm resistor going from the adjustment line, pin 3, to VF, the voltage out, which eventually want to be 5 volts, but we're going to make it adjustable for right now. So what I'm going to do is I will put my resistor across these two. The other part of the voltage divider is the potentiometer. That's the 5 kilo ohm symbol there for the resistor. Now the arrow through the resistor indicates that it's variable. Basically that it turns through various values. Now, I don't have a 5 kilo ohm. Instead I only have a 10 kilo ohm, but it's adjustable through this little screw here that I can change, like that. To be the voltage out is going to be in proportion to the ratio of R2 to R1. You know what? I can't remember which one was R2 or R1. So we're just going to try it. To arrange my circuit diagram, I have voltage in here, so that'll be going to my plus terminal. I have pass going from voltage in to ground. That's going to be going to my minus terminal. I have a 5 kilo ohm, in this case a 10 kilo ohm, variable potentiometer going from ground to the adjustment line. I have a 330 in this case going from my adjustment line to my voltage out. So that's where I want to read. And by the way, when you're measuring resistance on a potentiometer, you have to pull it out of the circuit. So to do it when it's in the circuit, the voltage going through the circuit will mess up your multimeter and give you bad readings. So you always got to pull it out if you're going to look to see what the actual value is. So now let's actually measure the amount of power going from here to here, powering both sides of it. So looking at this again, we have 6.47 volts on the end. Where's my 6.47 volts. This is going to be in and out. And let's measure now the voltage on the output again, just out. Just to confirm. Just can't remember what it was. 3.91 coming out. 91 volts coming out. So this is our voltage. Now I want the current. There we go. So it's showing negative because I just have the leads crossed. So 15.6, 15.7. So what we put is 15.65. Measured again just for convenience. Yeah, 15.6. Okay, so that 0.0156 amps. Now we're going to do the same thing across
one minute left.
The across the resistor here. Now I got to break the circuit, so I will. And I'll put this here, here. Now I get 11.7 milliamps. Or, got my power. That. Now, figure out how much power is going in, how much power is going out, and multiply these two together. So we're trying to look at the power in versus the power out. We're putting in 6.47 volts at 0.0156 amps, or in other words, 0.101 watts. Getting out of it 3.91 volts at 0.0117 amps, or 0.0457 watts. Look at that. We're putting in 6.5 volts, getting out 4 volts, and seeing almost half the power is going into the heat of the system. So in other words, this is a very inefficient system. And what we'll talk about in class is how you make a more efficient system when you need it. However, for a simple circuit, linear regulator is fine. Now, where does all that power go? It goes into this heat sink right here. And as you make your system, depending on how much load you have, that's going to get hot on you. As a matter of fact, you see it has a little screw hole there, so you can put it against a heat sink in case you get actually a much higher heat capacity you need to dissipate.